Hey everyone. Our talk is called Today Verkle plus Tomorrow ZK equals everything stateless, everything Lightclient. So my name's Jason Chaskin. I do various different research projects at the Ethereum Foundation. And in the first half of the talk, I'm going to give a high-level kind of beginner to intermediate overview of the benefit of stateless clients and what they are.
And I'm Gajinder, and I'm a code developer, and I do a little bit of research as well. So I'll talk about the endgame of ZK Ethereum.
Yeah, so before I go into explaining kind of what stateless clients are and how they work, I think it's worth it to give a quick shout out to the stateless clients teams and everyone else that's researching stateless clients, because I'm just somebody that tries to explain them simply, but without the hard work of people like Yom, who just spoke, Ignacio, Josh, and so many other people, like none of this would be possible. So maybe give a quick round of applause for them. Okay, so there's some common misconceptions that if you want to run a node, you're just doing it for altruistic reasons, or that you need 32 ETH, and neither of those two things are true. There's other reasons, including getting trustless information about the blockchain. Maybe you want to know your balance of ETH, and you don't want to trust Infura or centralized RPC. You can run a node yourself, and on top of, instead of asking them, since they don't have a record of all your asks, now you have that private lookup access, and we know what Web 2 companies do with your data, so we prefer to keep that private. And you also have trustless broadcasting of your transactions. You have direct access to the P2P network if you need to broadcast your transaction. And of course, it strengthens the network decentralization. So for all these reasons, I wanted to run a node about 8 months ago. And also, I felt well, before we go there, who actually does run a node here? Please raise your hand. Okay, about a third of the room. And I went to a couple of Vitalik talks, and he loves to ask this question, and I never had my hand raised, and I felt left out. And for that reason, and the ones I just mentioned, I really wanted to run a node. So about 8 months ago, I posted on Farcaster, and I tagged Bountycaster because I'm a hardware noob, and I needed help setting it up. So I asked for someone's help to help me run to walk me through running a full node. And thank you to Limes, who's actually in the crowd here, for telling me what hardware to buy and how to set it up. I hope you didn't spend that ETH because it's worth more now. And so the first step I did is I went and I bought the hardware. I spent $600 to get a new computer and around $150, a little less, to get more storage, because you need some more storage to run an Ethereum node. Total cost about $740. And then I actually set up the node. Like I said, I'm a hardware noob, so I kept copying and pasting things into ChatGPT. This process was a lot more confusing than I thought it would be. It took a couple hours, and I was pretty pumped once I finally got my node syncing, so I took that screenshot there. And then I left my computer and went back a day later, and my node was finally live, processing blocks, totally synced with the network. And this whole process was a pain. I definitely understand why not all the hands were raised. You do get benefits, but it's a really pain to set up the node. Now I'm going to walk you quickly through why this process took so long. It took over 24 hours to get live. And first, it's because you actually need to get all of the previous blocks. And this process takes time. If you're in blockchains big, you don't necessarily need them all, but you need at least some of the blocks. And you also have to load up the current state. The current state is the current amount of ETH that all accounts on the network has, as well as the data that's stored in smart contracts. So you need to know that I have 2 ETH, Gajinder has 5 ETH, you over there in the crowd have 6 ETH. And then you also need to know the current state of Uniswap, Aave, and all of our favorite smart contracts. And this process takes a long time. You have to go into that storage that I told you that I had to buy later and update everything to make sure it's live. And that's why it really takes over 24 hours. So now, once the blockchain is live and you're synced to the network, what happens when you're verifying blocks? Well, in the first couple seconds, you receive the block from whoever is the randomly chosen block proposer. And then you do the very simple checks. You check to make sure all the signatures are valid. You make sure it's the correct proposer, all the header stuff is correct. And then you actually have to go through transaction by transaction, and each one access your node's state and see, okay, if Alice sends Bob 1 ETH, does Alice in fact have enough ETH to send over? And then you have to update the amount. So subtract 1 ETH from Alice, add 1 to Bob, and you have to do that for every single transaction that is in the block. And there's something called the state growth bottleneck of all blockchains have to suffer through this. And as the blockchain gets bigger and bigger and bigger, it takes longer to actually look things up in the state. So in the Ethereum in day one, it's easy, just add on one account and update it 1 ETH. But once the node is really, once the state is really big, you have to go find that one account you need to update. And then that process keeps getting bigger as the state gets bigger. And I'm going to hammer that home with an analogy in the next slide. And the processing time takes around 300 to 600 milliseconds per block. In the last 8 seconds, there's some consensus voting stuff that we don't need to worry about. All right, now let's hammer home the state growth bottleneck. So first, let's take a look at that graph by paradigm. It's really awesome. They're producing really great blog posts going over how we can raise the gas limit. And as you can see, it's up and to the right for both history and state. We've invented up-only technology, just not in a great way, because you have to keep updating your storage as this gets bigger and bigger. And now let's go through the state growth bottleneck problem. So imagine that I'm a mailman in New York in 1800, and I have to deliver 3 letters. In 1800, New York's not that big. Maybe it takes, I don't know, who knows how long. It's a small city. You deliver all the mail. Now you have that same 3 letters, but imagine you're delivering them in New York today. The city is massive. Who knows how long it's going to take you to deliver that? So that kind of shows, even though it's the same 3 letters, it just takes longer as the city gets bigger. Ethereum blocks are the same way. As the state gets bigger, it takes longer to actually go through the transaction list and update the amounts. Now let's talk about running a node in a stateless world. You don't need to buy any new hardware. Just use your computer that you already have. And you don't need to buy new storage. Your storage is good. You actually barely need any storage. You choose and install your clients the same way, and boom, you're near instantly live. You don't have to wait 24 hours. Click your "that was easy" button if they still make those. I'm going to quickly walk you through technically how it works. Somebody who builds the block does still need to hold the state. So either that's a builder, maybe it's a solo staker that chooses to keep the state because they want to build the blocks themselves. And when they create this block, they also attach what's called a witness. It's called an execution witness. Now this witness, they actually create a proof of all the state that's touched. And in this proof, it cryptographically 100% proves that all the state that's touched is in fact part of Ethereum's current state. So in my example I keep using of Alice sending Bob 1 ETH, it might say Alice 100% does have, let's say their starting balance is 2 ETH, and it's sending to Bob who has 5 ETH. The proof will prove both Alice's balance of 2 ETH and Bob's balance of 5 ETH. And then your stateless node, you receive this block and the witness, and you don't need to look up anything to confirm it anymore. And you could actually do the entire block processing in RAM, which is an extremely fast, think of it like a trackpad, where you can just quickly jot things down. And so this process is a lot more efficient because you don't have to go into your state and look things up anymore. One thing I do want to mention is these proofs need to be compact. This wouldn't be possible with Verkle proofs just because they're too big. So we've slayed the state growth bottleneck. The L1 will actually be able to process blocks 3 to 10x more efficient. And yes, this means we're scaling L1. Gajinder is going to talk about scaling L1 even more. And if anybody tries to FUD and say Ethereum's not scaling L1, just send them a link to this presentation because that's not true. But I'm just getting started. One thing that's super exciting is we're going to actually be able to build these stateless nodes into your wallet. So because they sync instantly and because you don't need any storage, you're going to pull open your MetaMask, and in the background, instead of connecting to Infura, you actually connect to a stateless node. And you get almost all the benefits that I mentioned earlier, and you don't even realize it. So this is definitely going to be possible in your browser and like possibly your mobile phone. So people disagree on whether it's going to be possible to run in your mobile phone. Marius from Geth, he thinks it might be possible, and he says Ethereum can grow from 10,000 nodes to millions of nodes. Dankrad also thinks it could be possible in your mobile phone. However, Ignacio told me that phones and smartwatches may be a stretch. However, in the endgame ZK, we'll definitely be able to run them on your phone and your smartwatches. And I want to talk about how important it is that we're going to have like maybe millions of Ethereum nodes. This quote by Vitalik really stands out to me. It's pretty much saying that like if it doesn't matter how many nodes you have, if they're all in the same group chat, maybe the foundation pays for people to run nodes and you're not verifying it yourself, you could wake up tomorrow and see that the foundation now has, or you won't actually see it because you're not running a node, but they just print more tokens for the foundation and people don't catch it until a couple days later. At that point, it's too late. They come up with some BS excuse that they need it for research or whatever, but that's just not Ethereum way, and it's not good enough. And I think Ethereum is like really inspiring in this mission to make sure everybody runs a node, whether they know it or not. Ethereum isn't just a tech startup, it's like a global public good for all of humanity. And I just find that so inspiring and motivating, and it really fires me up. So maybe let's cheer for that. So quick recap, with stateless nodes, you're barely going to need any more storage. The verification time is at least 3x faster. The setup is near instant. Definitely will work with your browser. Mobile device, number of verifying nodes, potentially millions. But wait, there's more advantages. We're actually going to be scaling L1, L2 because of this. The data layer scales, it's going to scale because of this thing called data availability sampling. And the more nodes that there are in the network, the more we can scale the data availability layer. And remember how I said there could be millions of nodes? Yeah, you do the math there. Also, they'll be potentially able to be better cross L2 communication. Because these proofs are going to be very small, we'll be able to easily send them to the bridge and verify that certain things are part of the L2 state, and it'll be easier to do new constructions where the L2 bridges communicate with each other. And the last thing is, in the witness, you know all the state that's being accessed. So maybe you decide you only want to process blocks if they touch state XYZ or whatever. Then you can do that because you have that witness and it shows you what part of the state is being accessed. And now I'm going to kick it to Gajinder to talk about the future.
All right. So seems like statelessness and Verkle, I mean, they sound like magic. We should really do it. And maybe with ZK-enabled Ethereum, we'll be able to push the boundary even further. So the endgame of ZK Ethereum can be seen through lens of state, compute, history, availability, finality. But I'm sure that everyone remembers scalability trilemma. So this trilemma is like, classical physics. Most of the work, most of the time, it holds. But then, like quantum mechanics, you can push the boundaries with some magic math. And as Jason has shown you, that when you run a node, you need TBs of space. And although most of the space is not used by state, only 15 to 20% is used by state, but even if we get rid of that, but we would really want gigagas, and that would basically explode the state. So L2 sort of are a sharded state, and ZK rollups basically approximate that sharding a little bit well. But we also need engineering solutions to shard, slice, and prove the state. And for that, we need statelessness. And one can think of it like that almost complete removal of state without compromising security. So the other big thing that is on the EL clients is the history. And even though that history is not really complete, we need ETH logs. But there are ways we can do less uncharted history. EIP 4444 solves it a little bit, but what we need is ZK-friendly accumulators and filters for rapid global indexing and lookup, and obviously engineering solutions and products to shard, slice, and prove the history. For computation, we can do distributed block building with ZK EVMs, with verifiable state transition. Maybe we should also enable huge smart contracts like the way Verkle does, with a unified tree, provable code chunks, on-demand loading. For availability, we have blobs. We are pushing sharded blobs, basically jointly verified data availability. And maybe we should also do sharded transaction mempool. Finality, we have Orbit, but we can push it even further with having multiple committees with ZK verifiability, easy ZK aggregation, which gives us fast ZK verifiability and could lead us to have faster slot times. So we would want to see the protocol as some of its Lightclient parts, and all these are composable but provable islands of state, compute, history, availability, finality. And the magic sauce behind this could be statelessness and ZK. And the common thread behind that is polynomials, because polynomials are ZK-friendly constructs that can encode high amount of data and commit them to small size evaluations. So state, history, computation trace. It can be mapped onto polynomials and one can generate succinct proofs in size and verifiability, but there is a downside, that it's a little bit resource intensive, but there are some strides that have been made recently, circle stocks, miners, but we believe that the further research into it will unlock more performance. So with statelessness, so we can conclude that not all participants are going to be same in the network. Not all participants will have to do all or same work. Work done by one can be used by many. There is some centralization risk, but it is mitigated by easy verifiability and highly decentralized attestation network that can be built on top of it. And we can have sharded engineering solutions to basically mitigate some of the centralization risk, where I think portal network could play a big game over here. So we might go into an era where no one is a full node or a participant. But all this composability needs to be protocoled in. But I mean, there is a lot of hard work that is still ahead, and a lot of research that is still ahead. So we should be a bit cautious in our excitement. But anyway, I mean, I think Ethereum can provide this really exciting ZK future to its users, where you can have fast transactions, you can have smaller clients, nodes, and basically you can have bridges that are light clients, and they can verify, and you don't really have to have full node running. So I guess there is exciting times ahead for sure.
Thank you very much for the wonderful talk, Gajinder and Jason. So turning our attention to questions. In a rollup-centric world, a lot of the state is in blobs and users are interacting with rollups rather than the L1. Can you talk about statelessness in the context of L2 sequencing?
So as I said, ZK-based rollups are essentially a very good approximation to a sharded state. That they have the data that they post to the L1 smart contract, they post verify, they post proof of that, they post proof of state transition, and that gets accepted. So in a manner, they are like a sharded extension of L1, although with ZK VMs, you don't even need a blockchain sort of execution environment. You can basically have any kind of data structure that you want. You can commit to it. You can have your, whatever is your logic that you update that data structure with. You can do that, and I think you don't need even an L2 for it.
How can stateless clients be used to increase DA if running on phones or laptops with limited power that are not always online, and they have no stake to slash if they withhold data?
Well, this is just sampling. So it's not like they're proposing blocks in this world. Like I mentioned, if you want to propose a block, you still are going to need the state. These are just additional nodes that are sampling the data.
So basically, what essentially one can do is that you have these small nodes which can easily come up using Lightclient protocol, and then you can get that data and build, for example, fraud proofs if they are there, or you can actually verify whether, if, for example, there is a ZK proof of state transition, you can verify that. In a ZK state transition based world, this would not be an issue because smart contract will not accept it. But if it does, I mean, that is sort of a bug, and I think the social layer will take care of it.
What trade-offs do we have with statelessness?
So the trade-off with statelessness is against the resource that is out there. For example, if you have seen in one of the memes made by GM actually, that if everyone is statelessness, how will you build the blocks? So there is particularly, you have to rely on builders out there who have full state, or you have to rely on decentralized infrastructure provider like Portal to get the state, and then you will have to build it. So there is some centralization risk, but we believe that a highly decentralized attestation network is actually more important, and we can make sure that if the cost to block building isn't too high, then at any point, if there is a risk, any number of builders can enter the ecosystem and start building.
And we're already actively working on like distributed block building methods. So if you want to follow along on Ethereum's YouTube page, there's already been a breakout call for distributed block building.
If stateless clients exist, what's the incentive for normies to run full clients?
So in my vision, normies wouldn't run full client. They would, for example, interact with something like Portal. They might still process transactions, get the state from over there, give it to, submit it to the transaction of the nodes, and they will do their consensus rules and make it part of the blockchain. But again, the incentive is block building for sure if they want to run a full node.
Yeah, and that's also kind of part of the point that I was really trying to hammer home. They're going to be running these nodes kind of whether they even know it or like it or not. So the incentive doesn't matter as long as they're built into the wallet, they're going to be running it.
How are conflicting concurrent transactions going to be resolved?
So, I mean, this is more a research-oriented problem, and in my belief, so basically, when you apply a transaction, when there is a stateless transaction that you will apply, either if it accesses a state that has been modified, or if it's accessing a new state, because smart contract execution is Turing complete, and if, for example, dynamically, if there is a change in value, it could totally access another state. If that happens, you will not include it as a part of your block, and that transaction will be resubmitted again, unless you are a full node and basically can access that state or get it from the Portal client, from the Portal network, and build the block.
When?
Guillaume? All right.
Great. What's your opinion about people claiming that having 32 ETH means validators have money to buy more hardware?
You don't need 32 ETH right now, even with 8 ETH or even with 1.5 ETH. I don't want to shell the protocols out there, but you can run a validator and your reward will not match the cost of running the hardware. So,
what's the role of L2s in a Verkle plus blob or ZK future L1?
The same thing they are today. We want more space, more transactions where you're inheriting Ethereum security.
Okay, and does this work only with DAS? What if committee doesn't distribute the block over the network? What consensus modifications does it require?
If a committee doesn't distribute the block, then the block never gets imported because the consensus clients don't import it. It never gets part of the chain. There is data availability checks, and this is further even enforced by data sampling, that even if you have sharded data that you have you have imported and because you want to custody it, and then there is a whole bunch of other data that is out there that you are not sure whether it's available or not, but then, for example, PDAS runs a sampling protocol, and full DAS will also run a sampling protocol on top of it to make sure that the peer that you have, they have the data that they claim they have, and on the whole, if you look at the network, there is some probability that they might not have other data that they say, I mean, they have imported the block, but they might not have other data. So there is some probability, but if there is a big network and if you have a good pairing, and if every honest validator or beacon client enforces this sampling, network as a whole will have the data.
All right, well, that's it for questions. Thank you very much again. We'll